Hello and welcome to Ulfberht. This is Qasim Zulfagari and today we are going to discuss about my new transmission concept. It's called the Ulfberht infinitely variable transmission. As we know, the CVTs are much more efficient than the traditional binary system of gear selection, like the manual and automatic gearboxes. But there are still downsides about them. They can't handle heavy loads. They need constant oil supply to build enough oil pressure for operation. They are still complex in terms of number of components. They still need the computer to select the gear. They require complex and precise manufacturing method, especially for the belt. And they are expensive. And I believe that I have solved all above problems in the new system. Main components are sun gear, planetary gears, ring gear, planetary carrier, input shaft, planetary blocks, valve body, flywheel, spiral spring, oil motor and oil pump. To better understand the concept, first we would have to know how can we get all the driving ratios including reverse from a single planetary gear. A planetary gear contains sun gear, planetary gears and a ring gear. Planetary gears will be connected to a planetary carrier, which will connect to an output shaft. And the sun gear will be connected to the input shaft, which is the crankshaft and the flywheel and so on. The neutral gear will be selected if there is no applied force between the components in the system. So all the components will ideal in their places and there is no output. And as we force all the components together, we will have same rotational motion for all the components, which eventually give us 1-to-1 gear ratio. And the reverse gear will be selected if the ring gear rotate on opposite direction of the crankshaft, but in faster speed. So we have to convert some energy from the crankshaft to the ring gear in order to rotate it. We will later talk about reverse. So for now, how can we apply brake to all the components to make them rotate in the same motion? We have two solutions. One is a friction disc and the other one is hydrostatic force. If we apply a friction disc on all the components, we will eventually rotate all the components at the same time. But when there is less than 1-to-1 gear ratio selected, we have too much of friction build up between the components and the friction plate. And this will lose a lot of energy. We can also use hydrostatic force. How to use the hydrostatic force? There is large empty spaces between the planetary gears. If we put a block to fill this gap, we will have an oil flow to high pressure and low pressure oil flow. And if we limit this oil flow, we will able to lock the whole assembly together. So the oil blocks, will be placed on the planetary gears space, and they will act like an oil pump. There will be 2 high pressure areas and 2 low pressure areas. As we limit the flow, we will be able to rotate all the components together in the same motion. And this will give us 1-to-1 gear ratio. So how to limit the flow? We have 2 ways. First is by putting a damper, by putting a variable hole on top of the high pressure and low pressure areas. And by limiting the flow inside the assembly, we can select the gears. But this is not efficient. It will lose all the energy. It will act like a damper. It will generate heat and it will lose the kinetic energy. Instead of that, we are going to use an oil motor. A variable oil motor on top of the assembly. The variable oil motor will decide when to take more oil or take more oil, which will result in higher flow, lower pressure, and when to take less oil, resulting on higher higher pressure in the system and rotating all the components in the same time. There are many types of oil motor that we can use. First is a hydrostatic pump, which is very large and it's already been using in the tractors. And then we have variable vane pump. A variable vane pump will allow us to have very minimal space, very small space, but it's still efficient enough. So till now we know how to limit the flow and how the limitation of the flow will select from neutral to 1:1 gear ratio. But how to select the gears? The gears can be selected by the CPU of the computer, of course. In any kind of machines that we are seeing, the CPU do the job. But we can do it mechanically as well. If we put a spiral spring inside the flywheel and connect the middle of the spiral spring to the input shaft of the gearbox, we will, dependent on the torque applying on this area, we will have the springs to be smaller or larger. So as they try to turn, the cavity between them will be elongated. So if there is high torque on them, the cavity will be elongated and less widened. So if we put a tube with a low friction material surface inside this assembly, we will be able to push the liquid through the middle shaft, through the input shaft, through the output shaft, and to the oil motor inner part. This high pressure liquid will select the gear automatically. The balloons that we are going to put in there going to have low friction surfaces based on putting carbon materials on top of them, and they cannot be stretched, so they cannot be elongated, but they can squeeze. When they can't be elongated, the pressure on the system will only push the liquid to force inside the input shaft. So it will travel inside the input shaft to the output shaft and offside the oil pump, which will result in high flow. So when we have high torque, we will have high flow. And this high flow will allow the gear to rotate faster. And when we have low pressure, we will have low flow. And it will select the 1:1 gear ratio. But how can we select the reverse? By reversing the fluid flow inside the whole assembly, we will be able to get the reverse. The reversion of the fluid flow will allow the ring gear to rotate faster than the input shaft. And this will allow the planetary carrier to rotate on opposite direction of the sun gear. There will be an oil pump behind the planetary gear set and after the flywheel. This oil pump will use the input shaft force to reverse the direction of flow inside the whole assembly. Thanks for your time, and this was the Ulfberht infinitely variable transmission.